Welcome to section 8.6. We're going to look at the ratio test is good for factorials and powers. When you're looking at it, it's going to fall into one of three categories. Your series is going to converge absolutely if the limit of its n plus 1 term over its nth term is less than 1. It's going to diverge if that same n plus 1 term divided by the nth term is greater than 1 or it equals infinity. Okay, and surely we all know infinity is greater than 1. The ratio test is inconclusive, which means we're going to have to try another test if that ratio equals 1. So it's a ratio test, so we're looking at a ratio of that, the limit of that ratio. It's the n plus 1 on top of the nth term. Okay, so let's take a peek at it. Okay, this is good for factorials and powers, so anytime you see that factorial, you are immediately going to go for that ratio test. Now, every time I'm going to take the n plus 1 term, make sure you write it correctly so you don't mess up. That's n plus 1 over n factorial, n plus 1 factorial. And we're dividing that, so we're going to be flipping and multiplying. And it is that absolute value. So we're going to be flipping and multiplying a lot. Well, now let's see if there's anything we can find that will cancel. Now when I look at this, I have the 2 to the n plus 1, the 2 to the nth. So 2 to the n plus 1 is just 2 to the nth times 2 to the 1. So we know that's going to cancel all of that good stuff out. Okay, so that cancels. Okay, and we're left with 2 up there. And we've got n factorial and n plus 1. Well, when I look at that factorial, remember you're focused on who's bigger. Well, the guy on the bottom's bigger. And how many terms is he bigger? Well, just that n plus 1. So that's what we're left with. Well, if I put in a really, really big number for n, that's going to go to 0. Okay, that is less than 1, so therefore my series converges. Okay, let's try another one, because these aren't so bad. Ooh, golly, that is all full of powers and nasty. So we're going to do that ratio test. We're going to do the n plus 1 term on top. That was an n plus 1 already, so n plus 1 is n plus 2. We're going to flip and multiply by that nth term. So we are dividing, but I'm just saving us that step by flipping and multiplying immediately. Okay. Then we're going to do the same thing we did before and split it apart. Okay, so looking at my my 2 n plus 6 and my 2 to the n plus 2, 2 to the n plus 1, they're only different by 2 to the 1 power. So I have that 2 to the 1 squared. This is going to cancel and leave me with a 2. Well, this guy's going to cancel and leave me with a 3 on the bottom. So I have a 2 up here, and I have a 3 down there, and I have that n squared. Okay, so if I were to multiply this numerator out, I would have my n squared plus 2n plus 1, and then I'd multiply it by 2. I'm just going to go ahead and do that. So I'll have that 2n squared plus 4n plus 2 on top. I have that 3n squared on the bottom. We know that when we approach infinity, we're looking at the highest power term on top against the highest power term on the bottom. Everything else is insignificant. So this is going to equal 2/3, which, once again, is less than 1. Therefore, my original series converges. Now, as you go through it, you're going to start to simplify a little bit faster. So for instance, if you knew up in this second step that that was going to equal 2/3, you can go ahead and write it. You don't have to FOIL that out. Okay, let's look at another one. Oh, this is pretty exciting. All right, so you've got the factorial, so we are going to do it again. The limit as n approaches infinity. You've got your n plus 1 term. And we're going to divide that by the nth term, so we're going to be flipping and multiplying. Okay. All right, so when I do this little guy right here, I'm going to have my n plus 1 to the nth term over n to the nth term. Okay, all that nice stuff's going to cancel there. And then I can rewrite this as n plus 1 over n all to the nth power, which if I simplify that some more, n divided by n is 1 plus 1 over n to the nth power. Now, this is something that we will have to kind of memorize, have in our memory banks here. This limit right here of our 1 plus 1 over n to the nth power, that is equal to e to the 1 power. And that is greater than 1. So whenever you see 1 plus 1 over n to the nth power, that is automatically e. E is 2.718-ish. That is greater than 1. Therefore, my series diverges. All right, let's look for the root test. The root test is very similar in nature. You've got converging absolutely if you're less than 1. You are divergent if you are greater than 1 or equal to infinity. The ratio test is inconclusive if it's equal to 1. So this part of it is exactly the same as the ratio test. Now the root test is good if you have something being taken to the nth power because you're going to be taking it to the nth root. So looking at this guy right here, I'm going to rewrite that because I really do like to see the quantity being taken to the nth power. So that would be e squared over n, all of that to the nth power, because remember, power outside of power you multiply. So now I'm going to take the limit as n approaches infinity of the nth root of e squared over n to the nth power. And we want to make sure that we write that all out, even though we know that that is going to cancel, to e squared over n. E squared's a bigger number than 1, but the same rules apply. Your bottom is getting very, very big, so that e squared isn't going to be able to hold on. That is going to go to 0, which is less than 1. So therefore, our series converges. Woo! All right, I know. Hold your enthusiasm. One more example. Okay, you can really see this one fits into the mold of the nth power. You got to show that you're doing the nth power by taking it to the nth power. I know, they're just crazy wanting us to show our work. Okay, so that's going to be 2n over n plus 1. Looking at your highest powered term on top against your highest powered term on the bottom, that's going to go to 2, which is greater than 1. Therefore, this little guy, I guess I shouldn't call it a little guy because it diverges. So the nice thing about the ratio test and the root test is it converges if that is less than 1, it diverges if it's greater than 1 or equal to infinity, tells you nothing if it's equal to 1. So root test, you take the nth root. Ratio, you form a ratio. The n plus 1 term is on top. I'll see you back in class.